Okay, welcome to chapter 18, part 4. So when we left off, we were talking about, I believe right here, if there's multiple substituents, figuring out which one is going to actually be the director. Continuing from there, Steric can play a part. I'm not going to try to trick you here. This is an OP director. It's bulky, so it is more likely to go to para, but it will also direct to the ortho position. Okay, now this is very similar. This is the same kind of idea. Both of these are OP directors. They're both R groups, and so they fall kind of in the same line of weak activators. And so if you think about the ortho, and they're directing to the same places here, and here. The steric hindrance is a lot right here, right? Because you've got the methyl group on one side and the isopropyl group. This is going to be the least steric with the least steric hindrance here next. It does direct here, but it's just there's so much steric hindrance, you're just not going to see it. Now, I want to only stop on this for a moment. I am not going to ask you about blocking groups in this chapter. We will talk about protections later, but this is going to show you how you could force an ortho position using a sulfonyl group. You can skip this. Synthetic strategies. That's where I want to talk about. That's what I want to talk about right now. If I ask you to give me the reagents that would take me from benzene to a substituted benzene, let's say we were going to do Br2, not Br2, just Br and NO2. I know that there's two reactions that I need. I need to add the bromine, I need to add the NO2. But the order in which I add them is going to be important here. So I'm going to purposely do this wrong so that we can talk. Let's say that I add my bromine first. If I use Br2 and FeBr3, that will put a bromine on the ring. But now what is going to happen if I add in HNO3 and H2SO4? You can't forget what we just talked about. Well, bromine is an OP director. All right, so if I put that one on first, well, the nitro group is going to go to the ortho or para position. So not what I wanted. So what I need to do is I need to add the nitro group on there first. All right, and that'll put my nitro group on wherever on the ring. And now it's a meta director. Now when I add in my bromine and iron tribromide, it will go specifically to the meta position. All right, so you have to be thoughtful here. When it comes to testing, if I give you a free response, I'm going to want you to type in the reagents you need, but also part of the problem is going to be making sure you put them in the right order, right? So that's a place where you actually can get partial credit if you know the reagents, but you get them in the wrong order, then you would get some credit. If you don't know the reagents, but you know that the nitro needs to go on first, right? You could say something like, this is just an example to show you how to still get points even if you can't think of part of the answer. So if you know the nitro group needs to go on first, but you can't remember these reagents, you can say nitro group substitution, and then if you do remember how to add the bromine, you can write in or type in those reagents. So synthesis problems are going to be part of our lives here, and they can be daunting, but they can also be a good opportunity to show me what you do know, right? So even if you get stuck, if you know that this is how I add a bromine and you know it needs to go on last, you can still get a lot of the points. You don't want to forget about some of these other reactions that we talked about, but we didn't do the mechanism, like the reduction of the nitro group, the oxidation at the benzylic position, the Clemmensen reduction. You can add bromine to a benzylic position as well. I don't know if this one's going to help you quite as much, but definitely these three are going to be necessary. So let's do a couple more problems together. So let's say I want you to go from benzene to a nitroethylbenzene. Now, we have to be thoughtful, right? You know how to put an R group on with Friedel-Crafts, but an R group is an orthopara director. So it can't go, you can't have an ethyl group and then get a nitro in the meta position. However, if I go in and I nitrate first, what is going to be the problem? Right? Yeah, I mean, I will wind up with nitrobenzene, and it's a meta director, but from here, no Friedel-Crafts reaction can occur. Because remember, a Friedel-Crafts reaction is going to be limited or blocked by a nitro group. It's just too deactivating for that particular reaction. So I need to be creative here. What's another way I can get an R group? Well, don't forget that you can do Friedel-Crafts acylation. So I can put on my 2-carbon chain and it will have a carbonyl attached, which is a meta director. So this is great. So now whenever I nitrate, and I can certainly put a nitro group on in the presence of a carbonyl, there are no rules about that, it will go to the meta position. And now all I need to do is my Clemmensen reduction, right? And so I will go in with my zinc mercury amalgam and HCl. Now what I would probably do in this particular problem is ask you for the amino group, because the Clemmensen reduction, it will likely also reduce the nitro to an amine. But for now, let's ignore that. I just want to show you how you can manipulate an R group into being a meta director, right? So this can be really useful for getting, two seeming orthopara directors meta to one another. You can always start off with the Friedel-Crafts acylation and reduce it with the Clemmensen reduction. So don't forget about that. And the order is going to be really important, right? If I reduced it first, then the nitro would still go to the OP position. The nitro group has to go on after the Friedel Crafts. So this is the only order that will give you this particular regiochemistry, this particular isomer. Another one that I really love to use, here we go, is something like this. Let's say we want a benzoic acid derivative. And let's put, well, we haven't looked at that one in a bit, so let's put a sulfonyl down here. Now, the SO3H is a meta-director, so we know that can't go on first. The carboxylic acid is also a meta-director, but the way that we're going to make a carboxylic acid should help us to see why we can get an OP director out of this. You cannot add, so if you're taking notes, just watch for a second. This is not a reagent that you can use for Friedel Crafts. This right here will get in the way and it will not behave the way that you're wanting. So, stop trying to use that. Okay, what you want to do is, you can use any R group as long as there's a hydrogen on the benzylic position. Methyl is just the most straightforward, but I'm going to do an oxidation, and so it's going to wind up chopping off everything past that benzylic position anyway. Before I oxidize it, though, I do want to add in that fuming sulfuric acid. I want to take advantage and get that pair position. Now, you might want to make this a longer chain, just for a practical sense, to kind of force the SO3H away from the ortho positions. But when you're doing a multi-step synthesis, for me, if it's an ortho para director and you get it and you just say it goes to the para position, I'm all for it. That's fine. And then in the last step, you can come in with that sodium dichromate, Jones solution here, and it will oxidize that benzylic position all the way to a carboxylic acid. Won't touch that SO3H. All right, so don't forget about that reaction. That reaction can be really useful for you. Okay, there are lots of different practice problems. Klein walks through another one here. This is a way that you can show your synthesis, just 1, 2, 3, 4, but please, you have got to number it. If you do not put the numbers, it's like if you don't have these numbers here, what you're saying is that you put benzene in a pot and you put all of the reagents in at one time. That definitely is not going to give you what you want. So make sure to number, please. There's going to be one more video, and we are going to talk about nucleophilic aromatic substitution. But if you want to read a little bit more about synthetic strategies, Klein is great. He loves to give some strategies. All right.